Okay, so we did our exploration. Now we're going to take some notes. Okay, so it says 3 ways a line can or cannot intersect with a parabola. Okay, the first way is it can intersect at 2 points on the parabola. And when that happens, we have 2 solutions. You saw some examples of that the other day when it connected at 2 points. It has 2 solutions. Kind of like when your parabolas, when we did just the parabola explorations, and when it crossed the x-axis twice, it had 2 solutions, because technically the x-axis is a line, right? So it's kind of the same idea. It can also intersect at 1 point on the parabola, which it would have only 1 solution. And then, of course, you could have it where it doesn't intersect with the parabola at all. And when that happens, there is no solution. So we're going to give you some examples today of when those happen, with the examples A, B, and C that you see here. And on the front side, our graphs came out really nice and pretty, and they came out really bad on the back. So the graph does not look like this on the back, so we're just going to make do with the visual that you see here, because it's going to be different than your actual paper. And I don't know why it came out so bad, but you'll see. So the first example, example A, it says y equals x squared plus 4x plus 3 will be a parabola. And then y equals 2x plus 6 will be this is a straight line. This is your linear line. All right. So they gave you points to graph the parabola. -4, 3, -3, 0, -2, -1, -1, 0, 0, 3, and then 1, 8. Now notice I don't give you an 8 on the other side, but that should reflect, right? So since these 2 points reflect each other, and this point is 1 away, if we go 1 over, this point should also be here. So this is my terrible-looking parabola. Okay. So if I do some graphs with the straight line, if I start at -4, if I put a -4 into there, 2 times -4 is -8. -8 plus 6 is -2. If I try to use the same lines that they did in the other one, -3 is -6, because -2 times 2 times -3 is -6. -6 plus 6 is 0. If I plug in a -2, that's -4 plus 6 is 2. This is just going up by 2 every time, right? So this should be 4, 6, and 8. So when I go ahead and make my lines at -4, -2 is there. At 3, 0 is there. At -2, 2 is there. At -1, 4. 0, 6. And 1, 8. Ooh, and I think I made the 8s off a little bit on the other one. That would be a little bit of a problem, because 1, 8 is up here. And this one's also at 1, 8. So you can even see on the tables the lines they share. If I try to make this line, it shares 2 points here and there. So it says the solutions are the points where the graph crosses or where the coordinates are intersecting. And those coordinates are at -3, 0 and 1, 8. Okay, or you look in the table, they share the graphs. Now, how can we do this symbolically to check it? Well, because we've been working on this, take the two and set them equal to each other. X squared plus 4x plus 3 equals 2x plus 6. So if I subtract the 2x to both sides and the 6, I get x squared plus 2x minus 3. Okay. And to factor these, okay, to get -3, that's -1 times 3 and 1 times -3. Well, which one of those add up to 2? The first ones, right? So you're going to factor that into x minus 1, sorry, and x plus 3 is what this trinomial factors into. So again, when I have those, I can set those equal to 0. X plus 3 equals 0, and x minus 1 equals 0. All right, so when x is 1, if I were to use the linear line, right? If I plug 1 in for x, I get 8. So there's your coordinate 1, 8. So that matches up above. And then if I plug the -3 in for x, again to the linear, I get 0. So our coordinate here is the -3, 0. And you can see that they match what the graph did, but doing it symbolically. Okay, so for the back, we're going to do kind of the same thing with them. Again, you can see my graph here is pretty bad, so we're going to try to figure this out without the graph. All right. So if I can do this with some coordinates, I can pick out just some basic ones. Well, I know that this trinomial can factor into x minus 5 and x minus 1, which means my x's are going to be 5 and 1 on the graph. So if I make this as 1, 2, 3, 4, 5, there's a point and there's a point on my parabola. And if I can find the vertex point, the opposite of b, which is 6, right, over 2a, which is 2, so 3 is the line of symmetry. And if I plug 3 into the equation here, 9 minus 18 plus 5 is -4. So this, we'll see how good I draw my parabola here. We'll see. Okay. Now, my linear line, I know is at +4. I'm a little off there. We'll see how that works here, because this line does not touch this at 4, by the way. Matter of fact, here, let's do this. I know my y-intercept for the quadratic is 5, because if I plug zeros in for x, right? So that I know that this is going to go up through there. So at 4, and then we're going down 4 and over 1. So my linear line is going like this. Okay. So as of right now, it only looks like it's sharing one point, which is that point. So let's test it symbolically to make sure, because that 1 point right now looks to be 1, 0. So symbolically, set them equal to each other. That's the best way to check things, or even sometimes the best way to solve it if they'd like to give you a choice. So add the 4x to both sides, subtract the 4 to both sides. X squared minus 2x plus 1. Okay. Well, I know that's going to FOIL into x minus 1, x minus 1. Right? Because negative 1 times negative 1 is 1, and negative 1 plus negative 1 is negative 2. So set them equal to 0, well, they're the same thing. Add 1 to both sides. X equals 1, x equals 1. So when you take it and plug it in, I don't know, plug it in the linear one, because that always seems to be the easiest one, right? Negative 4 times 1 plus 4. You get negative 4 plus 4, which is 0. So there's your negative 1, 0. That you can see that we've done things symbolically. Okay? And we just tested it. We did it graphically, and we did it symbolically. Okay? I'm just going to hold you 1 second here. We're going to pause this video for a second. It may not... Okay, and we're back. And I just had a beep on my headphones here that I'm starting to lose my connection here, so hopefully it doesn't kill my sound. All right, so we go to the next one here. Okay? This graph is a little interesting because this one, all right, this is the quadratic. We know it's at 1, 2, 3, 4. That's the point here, the y-intercept, right? And this is going up, so this is going to kind of go up like this. All right. Now, the linear line is at 1, so it's kind of going like this. So if you notice these two lines, are they ever going to touch? No. So watch what happens when we do this symbolically. Subtract the x to both sides, and subtract the 1 to both sides. So I get x squared minus x plus 3. Because again, there's no like term for x, and I did 4 minus 1. Okay. So you can't FOIL this. Okay. So when you can't FOIL, there's no solution. Okay. And visually, you can see there's no solution because these things do not touch. There's going to be no intersection. It's kind of like we needed two linear parallel lines. They never touched either, so there's no intersection point, which means there can be no solution there. And not to mention the parabola won't even touch the x-axis, so there's no solutions there either. So that kind of threw the whole thing off there. But when you see those graphs and those graphs do not touch, that's your no solution part of it. So the last example, down here at the bottom, example D, we're going to solve this one symbolically to figure it out. Okay, they're giving us a choice. Symbolic is the easiest. So I'm going to subtract the x and the 1. Okay. And again, if I try to FOIL this, I think we kind of did this one already, if I'm not mistaken. Yep. So it FOILs into 2x minus 1 and x minus 5. So again, set those guys equal to 0. Add 5 to both sides. X equals 5. Add the 1 to both sides. Divide by 2. X equals a half. So if I take the x plus 1 here and plug them in, well, 1/2 plus 1 is just 1/2, right? So there's your 0.5, 1.5 solution. And then if I plug it in the 5, I get 6. So this thing would have two solutions at this point, and at this point, the quadratic and the linear lines intersect. So hope you found these notes helpful. That is all that we got to do for today.